Here, I would like to look at another example where I'm given a graph and asked to solve the inequality. I'm not given what f of x equals, but I am told that I need to solve f of x is greater than or equal to 0. Notice on the graph, f of x is given by the solid lines here. And these lines would be understood to continue forever that direction and then forever up here, forever down, and then in this direction, and then forever up, and then here forever to the left, and then forever down. We also notice that there are these dotted lines in between my function. Those are what we call vertical asymptotes. We've talked about that just a little bit this semester. We'll talk about it in more detail later. For now, what I'd like you to know is that they are imaginary lines that my function draws very, very close to, but cannot touch and cannot cross. The x values that they go through represents x values that are not in the domain of my original function. So I need to make a note of those x values. Here it looks like it'd be -4, and here it looks like it would be +4. Now, we've spoken earlier about what this inequality means. The 0 indicates specifically the x-axis. Notice here that our inequality has a bar underneath it, which means that we actually could include the x-axis or values on the x-axis. The next thing is this inequality is specifically greater than or equal to. Because it's greater than or equal to, I'm basically looking on my graph and looking to see where the x's are either on or above the x-axis, since its symbol is greater than. So the on part comes from this being included, and then the above part comes from it being a greater than symbol. So looking back at our graph, I want to know where my graph is on or above the x-axis. Well, I look over here and I see that's not going to be part of the solution because my graph is actually below the x-axis. Starting here and going down all the way to the actual, looks like ordered pair 0, 0, I would be on or above the x-axis. Looking here from 0 to 4, it cannot be in that location because my graph is below. And then looking here, I can see that my graph is above. So going that way, and then looks like extending on to infinity. Now, something that we need to know is on this right-hand part that I've sketched, even though I'm going to the right, I'm actually going to stay above the x-axis, so I'm not going to cross that x-axis at any point to the right of there. So on here, I need the x values for which I'm on or above the axis. We notice that this piece gets infinitely close to that imaginary line x is -4. I notice also that it stops at the order pair 0, 0. And then here we get infinitely close to that imaginary line x is 4, and then we extend all the way to infinity. Okay, and so here our answer would end up being an x interval always. We would start at -4, we would go to 0. Now I want to talk about the endpoints here. Because -4 is not a part of the domain, even though the symbol that I have up here is greater than or equal, you cannot include the -4. The -4, that imaginary line you're drawing close to, you get infinitely closer and closer and closer to it, but you cannot ever actually equal -4. So anytime you have these dotted lines, you will always want to put a parenthesis around that particular value, regardless of what symbol you have in your inequality. Now the 0, we see that at 0, 0, we actually have a point on our x-axis. And so on this problem, since it was a bar under my original inequality, I would want to use a bracket there at 0. Then we would union this, starting up again at 4, but not being able to touch 4, so I would do a parentheses 4, and then going out to infinity. And this would be my answer. Any kind of polynomial or rational inequalities answer is always an x interval.